Hello, this is the first part of Unit 7, Lesson 3. This is about special triangles. The first special triangle that we're going to cover is the 45, 45, 90 triangle. This happens whenever you take a square and draw a diagonal. That the resulting figure that you have there is two 45, 45, 90 triangles. Okay, so there's some special relationships that you need to be aware of with these. Okay. Alright, for some definitions and things, here's what we got. We've got a square ABCD with one diagonal. Label the lengths of the sides as x and the diagonal as h. Okay? And the reason it's labeled h is because that stands for the hypotenuse of the right triangle that's formed here. As you notice, since this is a rhombus, the diagonal bisects the angles at the vertices, so this 90-degree angle is cut into two equal pieces of 45 degrees each. Okay, so now we have a triangle that has two 45-degree angles in it and a 90-degree angle. Okay, so whenever you see this, this means that not only do you have the two angles the same, that means the two sides are the same because this is an isosceles right triangle, which is another word for a 45, 45, 90 triangle. Okay, so if we take here, this is what this is telling us again about the interior angles. So that's where the 45-degree angles come from, as we already discussed. Okay, so what they want you to do here is they want you to draw the triangle that is the result of it. In other words, erase half of this square, take the information that you've got here, and then we're going to use the Pythagorean Theorem to find out what the hypotenuse is. Alright? So when we do this, we get h, which goes in for c, a and b are both x, so this gives us h squared equals x squared plus x squared. When we combine the like terms, this gives us h squared equals 2x squared. Divide both sides by the coefficient of x squared, which is 2, and what this gives us is don't worry about dividing, you need to take the square root of both sides, which gives us h is equal to the square root of 2x squared. The square root of x squared is simply x, so what we do with that is we bring it out front. So h is equal to x, which is the length of the side of the square, times the square root of 2. Okay, this is a constant relationship in this type of triangle. It's also used frequently whenever you have squares in problems. Okay, let's look at some more stuff. Okay, these following facts you need to memorize. Okay, and this comes directly from the Pythagorean Theorem that we just saw. Okay, the hypotenuse is always going to be x times the square root of 2, and the two legs will always be x. That means that these two angles are 45 degrees. Okay, you need to memorize this as well as the following fact. Okay, if we take a 1 and put in here for x, then this gives us this relationship, that 1, 1, and the square root of 2. Okay, that's a special case of it that you need to memorize. Okay, these come into play quite frequently, especially on SAT and ACT and most anything else. And this is another one of these things that will be with us all the rest of the year. Alright? Okay. Right here what they want you to do is they want you to use that fact that we used previous to find the lengths that are missing in this triangle. Okay? So we're told that this one leg over here is 3. Since this is 45 and this is 90, that means this has to be 45. Okay? So what they're doing here is they're redrawing this so that you can relate it to what you had. If you remember that one triangle where we had the 1 in there, this is 1x, this is 1x, and this is x square root of 2. Okay? So what they're telling you here is that 1x in this case is the 3. Okay? So we substitute that into the relationships that we know have to be true. So this means that AC, which is the length of this leg right here, since the one leg is 3, the other leg has to be 3. Okay, to get the hypotenuse, we simply substitute it in for this part right here where it has x square root of 2. So AB is equal to x square root of 2. Since x is equal to 3, that means that it's 3 square root of 2. Okay, notice that we have not done the Pythagorean theorem with this. We do not need to, because what we already did prior to this that you were asked to memorize tells you what these relationships have to be based on the Pythagorean theorem. Okay? Alright, they want you to use that same technique to solve this triangle. If you notice, this time they gave us the hypotenuse, and the hypotenuse is 6. Okay, so they redrew this over here to summarize their information, because 6 corresponds to the hypotenuse, which is x square root of 2. This means x times the square root of 2 is equal to 6. So x is going to equal 6 divided by the square root of 2. Okay, so we summarize that this way. The length of CB, which is this leg right here, has to be x, which is going to be 6 divided by the square root of 2. Okay? AC, which is also a leg of this triangle, and it has to be congruent to CB, it is also 6 square root of 2 for the same reason. Okay? Alright. And that's the end of this one, because we're going to introduce some new concepts in the next lesson. So you need to have any questions you have about this, and we will cover it before we do any work. Okay? Thank you very much. See you next lesson.